Hello guys, in this video we'll be discussing about the queues. Uh, let's start. Okay, here we have taken a simple picture representation of a queue. Queue is a linear data structure in which it follows an first out system. I mean, whatever the elements we are added at the first, it will be popped up at the first itself only. Okay, for example, let us consider this is an queue. Here, insertion and deletions will occur at the rear. I mean, whatever if we are going to insert the element, I mean, we are with the help of rear we are going to insert. If we are going to delete the element, we are deleting with the help of top, but it will be deleted at the first element. I mean, at the starting position. After that, this is array that is equals to size minus one. I mean, whatever the array present, it will be if it is maximum, then array double equals size minus one, and front is at the front. I mean, this is n queue, and if you want to insert the elements, this is the n queue, and we want to delete the elements, this is the d queue. Okay, and it follows first in first out FIFO system, and it is an linear data structure. Data structure. Okay, after that, let's move on to coding part. Okay, here uh, we'll be performing three different operation: insertion, deletion, and displaying of elements in our queue. Okay, operations on queues. Okay, uh, I have taken this code so that it won't be lengthy for a video. Okay, here this is our header files, right? After that, we are going to define the size. Has defined size, for example, 10. Okay, we have to in unlike stacks we have two, right? Unlike we have in stack we have only top, so but we have here rear and front, so we'll be first at the starting we'll make them I mean what we say, we'll make it minus one. I mean, it will be conjugate nowhere else. So for example, has defined uh, there is no one for enter size, no enter front equals to minus one, rear equals to minus one. Okay, and void enqueuable, this function will add the elements into our queue. Dq, this function will delete the elements in our queue. And void display, this function will pop up the elements. I mean, whatever the elements present in our queue will be displayed here. Okay, enqueue, dq, display, and are we missing something? And front, rear, and okay, we have forgot to give the queue itself, right? Enter queue of 10. Okay, front equals to minus 1 and rear equals to minus 1, and let's initialize I itself only. Okay, let's move on to option. We have taken this while loops executes until and unless we are going to exit from the loop. Okay, here we are going to give the options. For example, enqueue, and second option is dq. Third option is display, and the fourth option is exit. With the help of while loop, we are going to, I mean, with the help of switch, we are going to change the options, right? For case one, enqueue will be performed, and we are simply breaking this after the execution of case 1. case 3 will be our display all, and the fourth will be default. Invalid option. Okay, we have declared four cases, right? Case 1, case 2, case 3, and this is the default. Okay, let's move on to first. We are going for the enqueue part, right? Void enqueue. Okay, whenever we are going to press the option 1 after printing, then we'll getting the enqueue part. We'll be entering. Okay, first we'll write as printf enter the element. Okay, scanf percentage d. For example, take enter I element, and then we are going to scan I element, comma ampersand I element. Okay, we have read I element. So firstly we are going to check if our stack, sorry, if our queue is, I mean, full or not. I mean, if the queue is full, we can't add more elements into the queue, right? So first, with the help of if condition, if for, I mean, whatever the, if it is full, we are, with the help of rare we are going to find it. I mean, if rare double equals to size minus 1, for example, if we take here in the picture, I mean, this is rare, right? I mean, if all the elements are filled, I mean, for example, 10, 20, 30, 40, 50, 60, and if rare is at the end position, then there are queue is full, right? We can't more add elements. So for that, if rare double equals to minus 1, we have to write as queue is full. Okay. After that, if it is not, then we have to increase the rare plus plus, and we have to insert queue of rare equals to I element. Okay, that's it. And then move on to, let's move on to our DQ part. And here we have another condition. For example, if our starting elements, I mean, if we are going to if our friend is 0, I mean, if our friend is at the position of 0, we have to increase it, right? I mean, not if our friend is having minus 1, it is not pointing to another, then we have to make friend as 0 2. Okay, let's move on to DQ part. DQ. Okay, here if front is minus 1, then there are no elements present in it. Okay. Else we are going to increase the front plus plus only if we are going to uh, front plus plus. Before that, we are going to store the element, right? Enter D element. Okay, so D element will be Q of front, and after that we'll be printing the element percentage T. Okay, after that we have to decrease the top, increase the top plus plus. Okay, and here we have another condition. For example, uh, if front double equals to minus 1, right? And or else if, and our top and rear are at the same position, I mean, after the deletion of element, we have to make them top and rear as minus 1. That's it. Okay, let's move on to display part. Okay, for I will be iterating from 0. I mean I should not equals to front. I mean front not equals to -1, and as well as uh, I less than or equals to I less than red. So I plus plus, we have to printf percentage d q of I. Let's print here elements in our queue. Elements in our qr. Okay. Okay, everything is fine. Let's once check it. Okay. Hmm. Yes, everything is fine. If it is front equals to -1, then what are we going to do? Uh, Front equals to right. Okay. Sorry, this is front plus plus. Front double equals to right. Okay, first in queue will be entering 10, and then if you want to display elements in our QR, okay, we have insert the element, okay, right, q of I. In q of rare equals to I element, right? Okay. Else rare plus plus q of rare equals to uh, okay. mm, Wait a second, guys. Equals to 0, I less than rare I plus plus q of I. Let's remove this part and write and display. Okay, our elements are not getting displayed, right? mm, Elements in our percentage d q of I. Okay guys, I'll look into this problem and solve it, and that's it for your video. This is the final code of the queues. Thank you.